IRIS-P is the instrument that we are using as the pilot instrument for the HETEC survey itself. It is one spectrograph. For virus, we're going to build 150 of these. And we've been using this one instrument on the 2.7 meter telescope at McDonald Observatory. Our first experiments were to just understand the type of galaxies we're going to get from HETECs. But from day one, when we put this instrument on the telescope, it was so obvious the great science that you are able to do with it. And so we got the graduate students involved, and we talked about the various science projects that can be done. And now we have 5, I believe the latest count is 5 student PhD theses on using the virus-P spectrograph, and it's been remarkable in that regard. One is trying to measure the dark matter around the edges of galaxies. And in this one, it works fantastically well because IRIS-P is able to gather an enormous amount of light from the sky at once. At the edges of galaxies, they're extremely faint, so you need an instrument that can cover a huge amount of sky at the same time, and that's where IRIS-P comes in. Another one is to understand how star formation happens in galaxies. What is interesting, one of the most important areas in astronomy now is to understand how stars are made. How you actually take a pile of gas and turn it into a bunch of stars that make a galaxy. This is a very complicated physical process. So the physics are messy, and the observations are messy too. So what you need is an instrument that can look at the whole galaxy at once. And we've never really had that before until we have an instrument like IRIS-P that can observe so much area of the sky at once. And so you get all the information from all the regions in the galaxy that are forming stars. And so that's where we're going to make big breakthroughs in understanding the physics of star formation.